My name is Karl Peterson. My area of research is microscopy applied to building materials. And I'm in the concrete materials group along with Professor Doug Hooten and Professor Daman Panesar. Little did I know that the concrete industry is another huge producer of CO2. And a lot of the research that goes on at U of T has to do with substituting other materials for the Portland cement, which has got the biggest carbon footprint, to help reduce the carbon footprint of concrete as a whole. One of the routine tests that's done for concrete is the counting of the air bubbles. And so this is a machine made in Denmark that just automatically goes through and collects all these images, and then at the end of the day, or the end of its 15-minute run or 10-minute run, it gives you all the air void size distribution and things like that. But what Claire's doing over there is the exact same test, but with flatbed scanners, and this is a Ministry of Transportation Ontario project. They do this sort of routine testing, and it's done manually, like with the stereo microscope like we've got here. And so we were just exploring cheap and easy alternatives for doing it with just a office scanner. We put a lot of fluorescent resins into materials so that we can study the cracks and porosity. Like this here was an 80 millimeter cube, and this is part of Professor Paul Young and Dr. Farzin Nasseri's work over in the Rock Fracture Dynamics lab. They've got these cubes that they put under different pressures and then can introduce different stresses in different directions and then study how things fracture. And they're really interested in how these cracks propagate. And so a lot of this work gets done next door in the X-ray tomography room. That's some equipment secured by Professor Giovanni Grasselli as part of a CFI grant. So he's got this X-ray tomography machine and is putting in materials that have been failed or materials just as they are to study their microstructure. So this block, after testing, was really fragile. So we stabilized it with the fluorescent resin, and then they did the X-ray tomography work. And then when they were done with that, we cut it up and produce what are called thin sections. So these are thin slices through the material, and then put them under the microscope back here. We can take a look at the fracture patterns in really great detail. I'm going to turn off the lights. So instead of the microscope, we just have a simple UV lamp that we would use for, not for looking at thin sections like the thing that's sitting under there right now, but maybe larger slabs or larger pieces of material to study the cracks. Professor Ron Mills, who I've got a picture of up there, he was a professor here and did a lot of the same kind of microscopy work that I do. And that's his picture and a little award he won for photography from the American Society of Testing Materials. And these pictures up there are from the late Terry Ramlakan, who worked in these labs and did a lot with X-ray diffraction and scanning electron microscopy. So there's quite a history of this sort of work at U of T. One of the interesting developments with concrete pavements, and they can do it with asphalt too, is pervious pavements to recharge to prevent it from going into sewage runoff. In the winter, I teach Earth System Sciences, which is a first-year course. And in the summer, I've been involved in the survey camp. And in the fall, I teach a graduate course where I teach people how to use microscopy tools like the scanning electron microscope here and use them to study building materials. The general public benefits in that the research, the whole objective is to increase the durability of building materials. So if structures can last longer, it's a lot cheaper in the long run if you don't have to replace things as often. You know, the big one in Toronto right now is the aging Gardiner Expressway. And you know, that was built at a time where they didn't really anticipate all the de-icer salts and other environmental factors that are leading to its degradation. And so this kind of research is geared towards improving the durability of concrete.